Good morning to everyone. Today we are going to take a class on propositional logic. And what is the proposition? The proposition logic is a statement based on the propositions. So a proposition is a statement that is either true or false, not both. Means if you are taking a statement, whether the statement is true or false is called it as a proposition. Then we say that the truth value of the proposition is either true or false. Means either 1 or 0 is called it as the propositional logic. Let us take the statement, elephant are bigger than the mice. So this is a statement. It is a statement. Yes, it is a statement. And it is also a proposition. Here we are going to find it out whether it is true or false. So what is the truth value of this proposition? The elephant is bigger than the mice is true. So these type of statements is called it as a propositions. Now this is also the statement. Some 520 is less than triple one. This is also a statement. It is also the proposition. Why it is a proposition? Here we are having a definite statement is there. Means we are going to find it out whatever the given statement is true or false. So the given statement is true is a false statement because 520 is it's not a less than triple one. Then we call it as a proposition. So proposition is nothing but it is a definite statement whether we are going to find it out whether it is true or false, but not the both. So coming to this statement, in this statement we are giving y is greater than 5. This is the statement, but it is not a proposition. Here, the value of truth value is depending on the value of the y. The value of the y that you are given it as a 6, then it is a true value. Other, it is a false value. So it is not a proposition. So a proposition is nothing but it is a definite whether it is true or false, but not the both. Okay. Then combining the proposition. So when you combine one or two propositions, then we call that proposition as a compound proposition. So in this previous example, we are having one or more propositions can be combined to form a single compound proposition. So in the previous one, so here x is less than y if and only if y is greater than x. So in this statement, this is the statement. It is also proposition because it is truth value does not depend on the specific value of x and y. So x is less than y if and only if y is less than x. If the value of x is less than y, then if and only if y value is greater than x, the statement is true. So this is called it as a compound statement. Here we are having two propositions out there. First we are going to find it out whether x is less than y, and next one we are going to find it out whether y is greater than x. Then this is also there. If the moon is made of cheese, then I will be rich. So in this statement, it is also a statement, it is also a proposition. So what is the truth value of this is this proposition is probably true value. So what is a compound proposition? In a compound proposition, if you are having more than one propositions, then we call it as a compound proposition. Like then, what are the different logical operators out there? These are the different logical operators. One is the negation, conjunction, disjunction, exclusive or implications, and by conditional. So, what is the negation? If the value of P is true, the negation of P is nothing but the value is false. If the value of P is false, the negation of that is the true is the negation of that thing. So this is what we call it as a truth value of a negation of a proposition logic. Means for having some P is a proposition, the negation of P is nothing but if you're taking the P value is true, the negation of P is the false one. Then this is called it as a conjunction. In the conjunction, what is meant by the conjunction? If you're taking P is a proposition and Q is a proposition, the conjunction that what we take it as, it's a combination of if both are true, the resultant will be the true. If any one is false, the resultant will be the false in the conjunction. Then coming to the disjunction, the disjunction is a binary operator. It is represented with the disjunction symbol. This is the disjunction symbol here. Then in this one, if both are false, the resultant will be the false. Let P and Q are the two propositions. If both are false, the resultant will be the false. That is called it as a disjunction. It is represented with P union Q, or true is true false is true is true, and false will be the false. So the difference between the conjunction and disjunction is, in conjunction, if both are true, the resultant will be the true. In the disjunction, if both are false, the resultant will be the false. If any one will be the true, the resultant will be the true. So then the next one is called exclusive OR. The exclusive OR means that P and Q are the two propositions. P exclusive OR means that P is true and Q is true. Then P plus Q, that this is the symbol used for the P exclusive OR is false. So if true is false is false. If any one is true, the resultant will be the true. That is called it as exclusive OR. Then implication. The implication is called it as if then. Let P and Q are the two propositions. P implies Q. If P is true, then Q is also true. Then if P is true, then Q is false. Then the resultant will be the false. If P is false, if Q is true, then the resultant will be the true. Then both will be the false, the resultant will be the true. These are all called it as the truth tables. Based on these truth tables, we are going to calculate whether the given proposition is a valid proposition or not. Then this is called it as a biconditional. In biconditional, you are having the P and Q are the two propositions are there. In P biconditional, if and only if P is true, Q is true, then the resultant will be the true. If P is true, Q is false, the resultant will be the false. If P is true, if P is false and Q is true, the resultant will be the false. If both will be the false, the resultant will be the true. So here you can observe, when both are true, the resultant will be true. When the both are false, the resultant will be true. Then any one will be the false, the resultant will be the false. This is called it as a biconditional. Then the statements and operators can be combined in any way to form a new statement. This is called it as a compound statement. Let P is one proposition and Q is another proposition. We are combining these two propositions by using a symbol, or like by using the conjunction, or by using the disjunction, or by using conditional operators, by using operators that we are going to combine the two propositions. These propositions are called it as a compound propositions. Now, in this one, we are having the P is there and Q is there. So P is a proposition. This will be the true and true, true false, false true, and false true, false and false. Then here, what is this symbol? The symbol is nothing but the conjunction symbol that you are using. When you are using the conjunction symbol, then what is this? The truth table of the conjunction symbol. This is the truth table for conjunction symbol. If both are the true, the resultant will be the true. If any one will be the false, the resultant will be the false. Now coming to this problem, in this problem, we are given that P is true and Q is true, then we need to calculate negation of P union, negation of Q, that we need to calculate. So this that we need to calculate here, negation of P union, negation of Q, that we are going to calculate here. So first we need to find it out negation of P. So what is the negation of P? If P is true, the negation of P is the false. So here, this is the false here. So here, P is false here. P is true, the negation of P is false. Then Q is true, the negation of Q is false here. Then we are going to find it out negation of P union, negation of Q. So here we are using the disjunction here. In the disjunction, if both will be the false, if both the things is false, the resultant will be the false here. Then coming to the second one, P is true, then negation of P is false. Then Q is false, the negation of Q is true. So if you're taking the P is true, negation of P is false. If PQ is false, the negation of Q is true. The negation of P union negation of Q is, it will be the true. Because the negation of P is false and true, it becomes true. So except both propositions are false, the resultant will be the false. If any one of the proposition is true, the resultant will be the true. So in this one, the resultant will be the true here. Okay. Then the next one, the next row, the P is false, then Q is true. If Q is true, then negation of Q is the false. So P is false, negation of P is true. Then if Q is true, negation of Q will be the false. Then we are going to find it out, negation of P union, negation of Q, then true false becomes a true. Then again here false, the negation of P is the true, then it is the false, the negation of Q is true, the negation of P union, negation of Q will be the true. So this is how we can combine two propositions in propositional logic. This is called it as the compound proposition. This one is called the compound propositions. Right? Then, so this is another statement will be there. We are having two propositions or there P and Q. Then what they are going to ask negation of P intersection Q and negation of P union negation of Q. So if you are going to take this, what is the symbol for, this is the symbol for conjunction symbol. This is the conjunction symbol. So in this conjunction symbol, if both are true, the resultant will be the true. If any one will be the false, the resultant will be the false. If both will be the false, also the result will be the false here. So you're taking P is true, then Q is true, then P conjunction Q is also true. If P is false, true, and Q is false, the resultant will be the false. If P is false, then Q is true, the resultant will be the false. If P is false, then Q is false, the resultant will be the false. So here, negation of P intersection Q. Here, what is the P intersection Q? The conjunction of P and Q will be the true here. Then the negation will be If it is true, the negation will be the false. If it is false, the negation will be the true. If it is false, the negation will be the true. Then if it is false, the negation will be the true here. Then negation of P union negation of Q. So negation of P in the sense this will be the false, true becomes the false, and Q is also true become the false. False disjunction with false is the resultant will be the false. The negation of P is false, negation of Q is true, then false and true, it becomes true. The negation of P is false, true, and negation of Q is false, then the resultant will be the true. If both are true, then the resultant will be the true. So this is another example for by compound propositions here. Let us take this as an example here. To take the discrete mathematics, you have to take in calculus or course in computer science. So here, first we need to find it out what are the propositions here. So what are the propositions here? First we are having the three statements here. What are the three statements here? The first statement is take a discrete mathematics is the first statement. Then second statement is take calculus is the second statement. Then the third statement is take computer science is the third statement. So the first proposition that we are going to take, P, takes the discrete mathematics is the first proposition. Then Q is the second proposition, take the calculus. Then R is the third proposition, take a course in computer science. Then how we can represent it in logical format? If we want to take the discrete mathematics, then you must have to take the calculus and the computer science. Nothing but P implies Q union R. So this is the one. Then what is the second one? When you buy a car from some motor company, Acme Motor Company, you get $2,000 back in cash, a 2% car loan. So this is the proposition that they are given. What they are given, when you buy a new car from Acme Motors, you get $2,000 back in cash, a 2% car loan. Let P is the proposal. We are having the three statements out there. One is buy a car from motor company. The second one is get $2,000 cash back. Then third statement is get a 2% car loan. Then when you buy a new car means a P implies implication. A P implies you get a $2,000 back in cash. So $2,000 means Q is a proposition which is going to describe get a $2,000 cash back. Then R is a proposition which is going to find it on which is going to represent 2% car loan. So here they are given in the statement you get a $2,000 cash back in cash or a 2% car loan that you'll get. Nothing but P implies Q XOR. P implies Q XOR. Q XOR R means what this is the next example. Then this is another example. School is closed if more than 2 feet of snowfall or if the work of the wind chill is below 100. The school is closed if more than 2 feet of snowfall or if the wind chill is below 100. So here you are having three statements out there. The school is closed, one statement, that is one proposition. The second proposition that you are going to take 2 feet of snowfall, and the third proposition that you are going to take the wind chill is below 100. So we are taking uh, three propositions here. Then what they are going to take here. Here or symbol is there. What is the R symbol here? Q intersection R, nothing but Q conjunction R. So when we are going to use the conjunction, if you are having or between the two statements, then you are using the conjunction. When we are using the disjunction, if you are having and between the two statements, then we are going to use the disjunction. So here we are having or between the two prepositions are there. Means if more than 2 feet of snow or if the wind chill is below 100, then the school becomes closed. So you're having the first preposition 2 feet of snowfall, nothing but Q. Intersection. Intersection means there they are giving or means that you are going with the conjunction. Then the next preposition is R is the next preposition. The wind chill is below 100. The wind chill is below 100. So Q intersection R implication P means if the wind is below 100 or the snowfall is 2 feet of snowfall will be there, then the school becomes closed. So Q in Q conjunction R implies P. So this is the next one. Then what is meant by equivalent statements? So what is meant by equivalence? Two propositional statements S1 and S2 are said to be logically equivalent. S is equivalent to S2 if they're having the same truth table, or S double implication S2 is a tautology. So equivalence can be established by constructing the truth table or without constructing the truth table. Then another definition is a tautology. Then what is meant by the tautology? The tautology is a statement that is always true. Let's take an example. Or disjunction negation of R. Or disjunction negation of R means if R will be the true, if R will be the true, if R is true, then negation of R will be the false. So here we are using the disjunction here. So true and false becomes the true. If R will be the false, negation or R becomes the true. Then false will be the true. So both the resultant will be the true. So what is meant by the tautology? If you are working with the propositions, the resultant statement, if all the rows in the resultant statement is the true, then it is called it as a tautology. That's called tautology. And the second example that what we are given is here. So the second example given here, negation of P intersection Q, double implication, negation of P, disjunction, negation of Q, negation of P conjunction Q, double implication, negation of P, disjunction, negation of Q. So this is another example that is a that is going to represent tautology. So understand what is meant by the tautology. The tautology is nothing but uh, the resultant statement is always true, then it is called it as a tautology. Then what is a contradiction? The contradiction means the resultant statement is always false, then it is called it as a contradiction. So, or disjunction, negation of R is always total. Or conjunction negation of R is always false here. Because if R will be the true, negation of R will be the false. Then in the conjunction, only true and true will be the true. The remaining all are false. So here R conjunction negation of R is false here. That will be the false. So then again, if R will be the false, negation of R will be the true. R will be the false, the negation of R will be the true here. So false and true, again it will be the false only. So the contradiction means if the resultant all statements are false, then it will be the false. So this is an example for equivalent statement. So this is a tautology. Let we are having two propositions P and Q are there. Negation of P intersection Q, negation of P union negation of Q, and then negation of P intersection Q, double implication negation of P union negation of Q is there. So here P conjunction Q. P conjunction Q means then true will be the true. Negation of P conjunction Q means it will be the false. Then P conjunction Q, true false will be the false. Negation it will be the true. Then false and true. Again it will be the true. Then false and false. The negation it will be the true will be here. Then negation of P, disjunction, negation of Q is there. Negation of P means false. Disjunction with false is false. Then false. Disjunction of true becomes a true. Then true. Disjunction of false becomes a true. Then true. Disjunction of true becomes a true. Then here what they are asking is double implication. What is the double implication? In double implication, true, false, only the false. The remaining all or the remaining all are true only. So here, negation of the intersection, um, this one, negation of P does P conjunction Q, double implication, negation of P, disjunction, negation of Q. False, false becomes true, true, true becomes true, true, true becomes true, true, true becomes true. So this is an example for tautology. This is an example for tautology. శ్రీజ అడుగుతాను రెస్పాన్స్ Srija, are you there?
Yes, sir.
Yeah, what is meant by tautology?
Like
What is meant by
all the
tautology?
true values should be tallied, sir.
Hmm?
Like after making a true table, all the values at the end must be true, sir.
Okay. So all of you understand?
Yes, sir.
Hope you understand. Right. Okay. I'm going to close the session.